let's get started with the contents of our today's course. And once again, sorry this recording had to stop last week, so now I'm a bit paranoid checking all the time. So today we are going to continue with our course, talking about using Python in GIS. I've been talking already a lot about like mentioning the library GeoPandas a few times already. Today is the time that we start to do something with it finally. So we will mostly work with the library called GeoPandas. As you can guess from the name, it's based on pandas and a few other libraries that you will see today, but it has the capability to work with geospatial data, with geographic data. So we will work with this library the next few weeks, but today we'll start with some of the basics. So we'll learn how to read and write spatial data from common file formats. We will learn to filter and regroup data based on the spatial and non-spatial characteristics, and we will learn to work with coordinate systems. Very important topics for GIS today. So to just make sure that we are all on the same page, these are the terms that we are going to use a lot today. Is any of these terms unfamiliar to you? Shapefile, geopackage, CRS or coordinate system, datum, EPSG. Yeah, so if you're familiar with all the terms, then I will skip this. Yeah, so the first part of our lesson today is not specifically about GIS, but it's a very useful thing. You're going to learn how to work with file paths in Python, and this is very important, especially if you're working with data files, because you need to provide the path to the data set you're working with to Python, and it can get quite messy if you have a big project and you have many files to work with. But before we start, as usual, let's open Notebook, log into your account. Okay, so you probably remember how to do this. I've done it already, but you should go to your My Work folder, and then probably last week you have created a directory called Lessons or something like that, and when you go there, you can just clone the latest changes. I've already cloned this. I have the latest changes for you. There is probably some orange sign here. Just pull the latest changes, then inside your Lessons folder, you should have a new directory called Lesson 2. And these are the contents of today's course, today's class. So we are going to start with managing file paths. So open this managing file paths notebook. Okay, so as I said already, working with file paths can become tricky, or at least it used to be more complicated until rather recently, when the 3.4 Python version was released only a few years ago. This got much easier. Before that, you needed to treat file path like a string. So if you wanted to give a new path, if you wanted to go inside a directory, you had to like manipulate this string. Like this is something we practiced a bit in the first course. But after 3.4 Python, a built-in library was added that makes our life much easier. So instead of, it brings us a lot of functionalities that makes it very easy to work with file paths. So what you're going to learn today in this part of the lesson is very useful if you're using Python for basically anything, not just GIS. So try to add it to your Python habits. So the Python package that we are going to work with is called pathlib. So as usual, you have to import the library so that you can work with it. Yeah, so one of the complications of working with file paths is that different operating systems have different ways of handling file paths. So for example, I guess Windows use like / to go into like directories. Linux-based systems do use /, and there are so many differences like this that make it complicated. So if you're sharing your code with someone else, well, first of all, it's a different computer, so the file paths are all different. So if you have used absolute file paths, for example, C drive, this folder, that folder may not exist, probably doesn't exist on that other computer, or it's named differently. Then it causes problem. But if you manage file paths like we do in this lesson, then you shouldn't have problem. Then you can share your code with anyone, and they don't need to update the file path regardless of what operating system they're running the code on. Yeah, so we'll start by importing the library, then pathlib.path. So it creates a path object to the current location from which you are running the script. In order to be able to look at it, we need to resolve the path first. This is something that you should always do. It's recommended.
Sorry.
Yeah.
How do you get the notebook to hide in automations?
Did you pull the changes from GitHub?
The pulling fails every time. Similar.
Okay, so just create a new folder and pull a fresh copy of the lesson. That's usually the easiest, fastest solution. So in the lessons, just create a new folder, call it like lessons 2, and just pull a fresh copy of the repository. Just copy the link from the website. So the link is here, just create a new folder and clone it again. It should bring you to some course environment from last week. Yeah. So let's wait 1 minute so others can catch up, those who had problem with pulling the changes.
Where was the link?
It's on the course website under course environment. Here. Did you solve the problem? Yeah, okay, good. Let's continue. Yeah, so you create the path object, then you resolve it. It should, so it shows you the link, the path to the file you're running, to the script that you're running. So now you can see this is where the file is stored, because we are running this on CSC, so it's some address on the cloud, and you can recognize it at least from here on. Then it's my works, lessons, notebooks, and so on. And this is telling you that this is, if you were running this on Windows, it would have said it's Windows. Now it's telling you it's some Linux-based machine. But you don't need to worry about it because this library takes care of it. So there are a number of functionalities that come with this. For example, if you want to check if a path is correct, you can just, once you create the path, you can just check path does exist, and it will return a Boolean value, true or false. So in our case, we are using the path that we have here, it's our file. So the path obviously exists. When you run it, it returns true. You can also check if the path is a path to the directory or a file. So with this path dot is there, which is like directory. Again, it returns a Boolean value. So So the path here is lesson 2, which is a folder or a directory. So it's telling you that, yeah, it's a directory. You could also do other things. For example, you can rename the folder. We are not going to do that. That's why it's commented out, because we are going to work with this folder. So let's not delete it or rename it, but just to let you know that you can rename a directory or a file. You can remove it. It's a different syntax if you're removing a file or if you're removing a directory. So if you have given address, if you have the path to a folder and now you want to go inside the folder, so you have to have a directory or a folder inside your folder. For example, in our case, now we are already in this folder, but we have another folder called data. If you want to go inside that directory, it's just very easy. So you have your path, you put a slash, and then data, which is the name of that folder that you're going to get into. So the path that you see here, you see it says it's Windows because I've previously run this on my own computer, which is Windows, but now that I update it, it will be updated to this because it's running from CSC now. Yeah, so now you see that you have a new path. It's inside this data folder. And if you want to go back one step, you can just use path.parent, and it just takes you one step back to the lessons folder. So one thing that we are going to practice a lot during this course, starting already today, is that at the beginning of your script, before you do anything, it's good to take care of your path. So it's a good practice to import this library at the beginning, and then you resolve it, and then you just have the home directory. So if you want to move, then everything is easy from that point on. So this is a piece of code that you will see a lot today and during this course, and it's a good habit to have. So we are going to use this already today. That, well, this is an example from GeoPandas. We are going to use the read file method to open a file. And you can see that you can easily, if you have already defined your data directory like we have here, we know this is like where all the data sets are stored, then you can just easily give the exact path to the file you want to open. So you just go to data directory, then this is another folder, and this is the name of the file that we are opening in this example. And then in this case, we just create a plot from this. Yeah, I will show you soon how to get rid of this warning message we get, but anyway, we got the output. Yeah. So this is, I guess, something we mentioned already in the first period course, that in many programming languages, you have a way of defining constants, so valid variables that you cannot update, and it's a good thing. It makes the memory usage and many things more efficient. In Python, we don't have that, but there is a good coding practice. If you want to define something as a constant, meaning that you don't want anyone to update that in your code, you just write it with capital letters. It doesn't really become constant, it's just a standard. It's a good coding practice. So we don't update our notebook path. It's something we are going to use during our script. So we usually write it with capital letters, meaning that it's constant during our work. Yeah, so we will use this a lot during this course and your work with Python. So if it's not super clear right now, don't worry. It gets more clear as you use it. Okay, so now that we learned how to handle file path, let's start with working with vector data. So open the other notebook file here. So using Python and the libraries that we are going to work with during this course, you can pretty much open any file format. So we are very familiar with shapefile, which is originally from Esri. We are also going to work a lot with this GPKG format, or this Geo package, which is a more it's an open standard, so it's favored nowadays a bit more because shapefile is SRIS. But anyway, basically any file you have, you can open with Python. Most of the current Python GIS packages rely on GDAL or OGR. This is something you might have seen in QGIS if you have worked with it a lot. And newer versions of it, for example, Fiona and Rasterio. Rasterio works with raster files. These are built upon this. So a lot of the terms, a lot of syntax can be a bit similar if you use different kinds of packages. So now we are going to start our work with some vector data and practice a few things. As I said, it's a good habit to start with defining our file path. So this is what we are doing now. We define our file path, and this is the location where we have all our data stored. So we don't explicitly use Fiona. Fiona is a library that helps you handle GIS files, but it is built in GeoPandas. Just to get an idea what files are supported in Fiona, you can run this code. So it gives you a list of formats that you can work with using Fiona and also GeoPandas. So there are some letters in front of the format, so you probably know many of these formats like CSV, shapefile, GeoJSON. And it says that R means that you can read the file using Fiona. W means that you can write this file format, so you can export in this format. And then you have A, meaning that you can append. So if you have data and you want to add a few rows of data to it, you can also append using this library. So it's pretty much all the GIS data vector formats that you will come across. Okay, so as you saw last time, I ran some code on the first page. When we were importing GeoPandas, we got some warning that doesn't affect our work, but the reason we get the well, let's try it and we see the warning, then I will explain. But let's start working with GeoPanda. We want to import some data. So what we need to do is first import GeoPandas. Now we are going to just use it like this, but very often you see that it is imported as GPD. So if you see this in someone's script, it's a common abbreviation. So let's just go with GeoPandas. So now we want to work with some vector data. It's basically the municipalities of Finland from year 2021. It is coming in GPKG format, and it is stored in your data folder. So I will write the path here for you. So let's create a variable and call it municipalities. This is the syntax we use for importing data, GIS data, using GeoPandas. So you use the name of the library. So it's quite similar to what we used to do with pandas. We have already defined the path to our files, so it's quite easy. So data directory. Then inside that folder we have another folder called Finland municipalities. And inside that folder we have a file called Finland this underscore 21, and the file extension is GPKG. To see what our data looks like, let's do something that we have done a lot in the first period, and that's the .head method. So municipalities. Yeah, so now we imported our data, which was in GPKG format, and we used the head function to see the first 5 rows of our data. So the first time you imported, you got some warning, probably because GeoPandas, there is an update to GeoPandas, and it uses Shapely. There is another similar library that GeoPandas previously used, and now both of them are installed in our environment. That's why Python is telling you that, okay, you have them both installed, and I'm using Shapely instead of PyGeos. So if you get tired of that error and you don't want to see it again, so you can just use this trick. So you just import a function called OS, and you can just set use PyGeos to 0, so it won't use PyGeos. So you don't see that warning anymore. But anyway, it doesn't affect your work. It's just to get rid of that red warning you see. So you see it only when you import GeoPandas. Probably you have all worked with shapefiles a lot. You know, shapefile is called a shapefile, but in reality, it's not just one file. You know, when you download the data from somewhere, it's a bunch of files. For example, you have .dbf, .prj, so it's a bunch of files. So it's very common to get it in zip format. One good thing about GeoPandas read file is that you can just provide the path to the file if it is zipped. You don't need to unzip your shapefile. For example, if you get it from some web resource, very often the link is to the zip. So it's very handy. You can just import it. Let's see an example of here. So we are going to import a file that is in zip format, not underline regions. If you want to learn more about this, some European level data, if you want to learn more about it, you can check the link here. So we use the same syntax, GeoPandas, read underscore file. I'm lazy, I want to just copy the path to the file from website. So this is the path to the zip file. You can see it's in zip format, but luckily we don't need to export it. We can just provide the path. And then let's use head to see if it was imported properly. Yeah, so you didn't unzip the file, it just unzipped it for you without seeing, and it loaded the shape file for you. Yeah, so if you want to save your file now, you just got your file in zip format from some online source. If you want to save a local copy of it for yourself, this is how you save file or export data using GeoPandas. So this is the name of our data, the variable in which we store the data, and the syntax you use is .to file. And then inside the parentheses, you should give the path to where you want to save the file. So we are going to save it in our data underline directory folder. Inside it, we create this new file, which we can call Europe nuts. And here you can specify what extension you want, in which format you want the file to be. Now let's try GeoJSON, which is another common GIS vector data format, especially if you work with web sources. Yeah, so once you run this, it just creates this data for you in the folder data. Another thing you can do, as I said, you can pretty much import data from whatever format, whatever source using Python and GeoPandas. So another example of this is if you're working with a database. For example, if you're working with PostGIS, you can use, there's a library called SQL Alchemy in Python that allows you to work with databases. So it's not only for GIS, it helps you work with any database. So we are not going to use databases in this course, but in case you need them at some point, remember that you can use this library to work with databases as well. Another source of data that is quite common with vector data is to get the data from a World Feature Service, or WFS. It is quite common, like in Finland also many like municipalities, cities provide data in this through WFS. So we are not going to go through details of this, but a couple of times we will see this example. So using this syntax, you can import data directly from WFS. And where does this syntax come from? It's basically from the metadata of where you have gotten the WFS service. So we are now getting this is where we are getting the data from. So it's a population grid of Helsinki. Probably I've seen this a lot. You can get it from Python, for example. So using this syntax, and you can get the vector data directly using WFS. So another example of how you can import vector data into your Python environment using GeoPandas. Again, we are not going to go through how to use WFS, but in case if you needed it at some point, good resources. When you get the data, there is metadata, so it tells you what is in the data and what is the syntax, what are these parameters that you need to use. And also in QGIS does a very good job of working with WFS. So if you just import your WFS in QGIS first, it will help you see, like you can browse what kind of data you have available and what syntax you should use to access it. Then you can just copy it and use it in your code. So here is just one example. Let's run it and see what we get. Yeah, so you might get, well, this is an online source, so depending on what's the situation of the website from which you're getting the data, you might get different kinds of errors. So for example, now there is a problem with the certificate. In order to get rid of that problem, uncomment this part if you're getting the same error. So we are basically telling Python that, okay, I know there's a certificate problem, HTTPS problem with the website, but I trust it, so just ignore the error and import my data anyway. So you can see that this data is just now fetched from that link using WFS. Any questions so far? Is everything clear? Okay, so now we did some basic things, just basically importing our data. Let's now get started and do some actual work with GeoPandas. So let's open the next notebook. This one, GeoPandas and Introduction. Yeah, so as I've said a few times already today and last week. GeoPandas is pretty much same as pandas, so whatever you learned in the first period, you can use it here as well. The only difference in GeoPandas is that, well, you will see an example of it later on, that you have a new column in which you have the geometries stored, and because of that new column, you have some extra functionalities that let you do different GIS things. So basically anything that you learned while working with pandas, you can use it here for like making any changes to your data, iterating. So all those things you learned in the first period will be applicable here as well. One difference, you remember that in pandas we worked with two types of data, and it was data frame if it was two-dimensional. If you had a table, it was called data frame, and if it was just one column or one row in your data, it was called series. So here the name is a bit different. So it's called geodata frame if it is a table, and if it's just a column in your data, it's called geoseries. So it has similar functionalities, just the name is different, reminding you that you're working now with GeoPandas, not pandas. So one of the nice things about GeoPandas is that it has brought in many good features and functionalities from different libraries. I mentioned pandas already. It also has Shapely built in and a few other libraries. So what we learned last week, we are not going to import Shapely anymore during that work because it's already accessible to us through GeoPandas. So that's a nice thing about working with GeoPandas. You don't have to import many libraries. Many things are already built in. So let's get it started. If you don't want to see that annoying red warning, remember to run this, uncomment this and run it. As I said, it doesn't affect your work. It's just a warning, not error. So now we are just importing some data and we want to look at it to see what geodata frame looks like. Yeah, I didn't run this, so I got that red message. Yeah, so this is basically the difference. So it looks, it's just a table like in pandas. The only difference is that you have this column, and inside that column you have geometry, and it probably looks familiar to you because these are the same geometries that it is defined by Shapely. So this is what we have practiced last week. So it looks like this to you. It's in well-known text format. So this is the text representation that you see, but like under the hood, what you see is actually geometry objects. But you don't see it. So what you see in this column when you print your data is this text representation, which comes in a well-known text format. So basically what we did last week. So in the rest of this lesson, we are going to work with the data set that comes from National Land Survey of Finland. So it's a big data, and it has a lot of files. We are going to go through the files a bit, like categorize different kinds of terrains and like export them as different feature classes. So this is what we are trying to do in the rest of the lesson today. If you want to check out the data comes from Python, so if you want to download it, you can go look, but now it's already available to you. It's in this data folder, so we are just going to work with it now. So as a first step, again, we specify the file path that we are going to work with. So the code is already available to you. Let's just run it. So there's a bit of explanation about the data that we are going to work with. So it has different kinds of features, and they are represented using different classes. So we are going to work with some of them and export them as separate files. So if you check out that folder, so this is the data we are going to work with. There are a lot of files. So if you check out the metadata of the data, you will see what each of them represent. But just looking at it, it's very difficult. This is an example of a case where working with like ArcGIS or QGIS can be quite annoying because there are a lot of files to work with. So you will see now with Python, it's much easier to handle this. So now if you are looking for a specific kind of file, for example, now these names that you saw, and the file names are not random. If you check the metadata that came with the data, it will tell you that they are named in a certain way to represent different kinds of terrain classes. So one good feature that is built in this pathlib library that we have learned to work with already is this globe method. So it allows you to list files based on how they have been named or how what their extension is. For example, using this kind of syntax, you can get all the files that have .shp at the end. So you have the path to the file and then .shp, and this asterisk here basically means that the name can be whatever. It will be listed as long as the ending is .shp. So now we are going to try and work with this. Okay, so let's provide the path to the folder where we had all those files. So let's call it topographic database directory. It is in our data directory / Finland and let's just print to see what is the path and whether we have any typos there or not. Yeah, I guess we don't have any typos. So this is the path to where the files are stored. So when you use globe, what it returns is an iterator. You have seen examples of iterators already. For example, you can use them in a for loop and go through them. But to make our life easy for now, we are just going to create a list, and everything that is returned from globe will be stored in this list. So I just pasted the name of the file path that we already created, and then I'm using the globe method. So what I'm getting now is all the files that start with M and end with P, and in between it can be anything, I don't care, so I just put that asterisk. But the extension has to be .shp. So again, this is no magic. I just have read the metadata that came with the data. I know that the files are named like this. So whenever you're working with data, you should have access to this kind of information. So now you can see that it just created a list. We have only one file that satisfies this rule we have. You see it starts with M, ends with P, and the extension is .shp. We have only one file, so we are going to work with that file. So let's create a new variable and call it input_file name. This is the file that we are going to work with. So I'm just going to copy this text again so that I don't have to type it again. I know what it returns already. We have seen it. It's a list with just one item. Because it's just one item, I only need the first one in it, which is the only one. So I'm accessing it. So it's a list. I'm just getting the one that has index 0 and store that file into input file name. Okay, so now we did some magic. We found the file we want to work with. Now let's use GeoPandas to work with our file a bit. We have imported it already, but it doesn't hurt. Let's import it again, GeoPandas. And now we are going to read our data using geopandas.read file. So we have already gotten the input file name, so it's easy. We don't have to like manually give the path. It's already there. So we just provide that as input, and it should open the data and store it in this variable named data. Okay, so now that our data should be loaded in this. Something that we have always done is to check the type of our data. So you can do it again with GeoPandas. It's not different. You can do the same thing. So let's see what kind of data we have in type using type function. So you can see that the data is loaded, and it's a geodata frame. So before, when we did it with pandas, it was a data frame. Now it's geodata frame coming from GeoPandas. Let's have a look at our data using data.head. So you can see it's a big file. You have a lot of columns. So now what we want to do is we see that we have 39 columns. If you want to more specifically look at the columns, similar to pandas, you can just write data.columns. And it gives you a list of all the columns, all the column names you have in your data. So we are not going to work with all of these columns, so it makes things a bit complicated and confusing. So again, something we are familiar with from first period. We are going to just select a smaller part of our data with only 3 columns and work with those. The columns that we need for our work are these. So data, so one of the columns we are going to work with is this column called Ryhmä, and then the second column we are going to work with is Luokka, and the third column, of course, we need is the geometry. If you don't import that one, it just becomes a Panda data frame. So we need to import geometry as well. Remember that you have to put 2 brackets because you're importing more than one column, and if it is more than one, you have to provide the list. That's why you have to put 2 brackets there. So now we are importing our data again, but only these 3 columns, and we store it in the variable called data. So now these names are in Finnish. We want to make it easier for some of us and rename them into English. So this is something that we have again learned before working with pandas. So again, we are going to update the variable data.rename. So you probably remember for renaming renaming columns in pandas, you needed to provide a dictionary with the old and new names. So we are going to do that. Here, columns equals, this is our dictionary. So Ryhmä becomes group. And Luokka becomes class. That this should be columns. So if you run this, now the data should be, the columns should be renamed to make sure everything went as we wanted. Let's use head again, data.head. And now we see the name of the columns have been updated to English. So this is something you can try later. You know, this is no different than Panda data frames you have worked with before, so you can try and get the number of rows, number of columns. You can do different things that you have previously done with pandas here as well, so you can later try that. So now I have been keeping you waiting for long enough. You probably want to already see some map, since this course is about GIS. So we will learn how to make fancier maps later, but just to visualize our data and have an idea what we just imported, you can use .plot, same thing as we have used before working with pandas. So if you just use data.plot, it should give you an overview of your data. So later we will get back to this and learn how to make better maps, but this is a good visualization. So you see the data is imported properly. And if you're already familiar with Helsinki, this data is from Helsinki, so you can recognize some of the shapes probably. Okay, so I have said already that we are using Shapely, even if we are not explicitly importing Shapely. So we are still using Shapely through pandas. So just to show you, you can access geometries separately. So if you write data.geometry.head, you can see that you can just access geometries, and you see the data type is geometry, like it's Shapely geometry as we learned last week. You can also try and do different things. For example, if you want to just visualize one of your geometries, like we did last week, you can just use data.add. Remember, again, it's pandas, so you can just provide the first row we want to try and visualize, and the column that you have geometry in is called geometry. Yeah, so you can just visualize, similar to last week. So it's not any different. Remember, we could have, last week we learned how to get the area of a geometry. You can do the same thing here as well. The code is already typed in, so you don't have to do anything. You can just run the code, and it's telling you that the area is 76 square meters. One difference here is that we have now unit. Last week we didn't have units because with Shapely we didn't work with units, with coordinate systems. Now we know that this data is coming in a metric system, so we know that it's in meters. But in the next notebook file, we will learn how to work with coordinate systems. So now let's try and calculate area for all the rows in our data. So in order to do that, one way is to write a for loop. Let's try and do it the old way that we learned in the first period. So we are going to make a for loop using index and row in data. So we are only going to do this for the first 5 rows in our data. And the way to iterate through Panda data frames was these iter rows that you're already familiar with. So we are going to use that to create our for loop. We create a new variable called polygon area, and that's where we do our calculations. So in each row, there's a for loop, so it's accessing each of rows one by one. We are going to use the column geometry for doing our calculation. For getting the area, you just put dot area. And then we are going to print the output. So let's just create an F string. The polygon area in row. Let's put the index value here. So this is what we calculated, polygon underscore area. It's enough for us if we just have one decimal. And we know that the unit is square meters. Yeah, so this is basically a for loop. You're going through the first 5 rows of your data and calculating the areas using geometry. So this is one way of doing this, but there is one more efficient way of doing this. So you don't need to write a for loop. What you can basically do is to write data dot area. So if you have a very large data set, it's just more efficient and there's less to type, of course. So it's just going to give you area calculations for each row in your data. So as you can see, this is, well, it's just one column. So it's a series. But what if you want to store it into a new column in our data? So again, something that we have learned previously. So we add a new column to our data and we call it area. And it equals data.area. So as you can see, it added one more column to your data and it was very quick. You see the data is quite large. We have 4,300 rows in our data, but it took a fraction of a second to just calculate the area for all of the geometries in your geodata frame. So this is something we learned from the last period to get descriptive statistics. This is something you can try at home. So it's like pandas. So if you want to calculate descriptive statistics for area, for example, see which one has the largest value, you can just check the materials from the first period. So in GIS, working with any data, and particularly in GIS, it's very common that we need to make a selection from our data. So let's try to select all the lakes in our data. We create a new variable and we call it lakes. And from data, we get all the data rows in which the data.class. So we have a column in our data called class, you probably remember. And again, from metadata, I know that all the class values, that's 36200 is equivalent to lake. So I'm getting all the rows where the class value equals this number. This should give me all the lakes. To make sure this worked well, let's plot our lakes using .plot. And looks well. So these are all the lakes from our data. Now if you want to export your data, just lakes, you can use toFile, so lakes.toFile, and then you give the path to your where you want to save the data. So we'll save it in our directory. In another folder called Finland topographic database. And let's save the file as lakes.shp. So this time you're saving as our file as a shapefile. Yeah, so now the file should be created. So if you go to this data folder, Finland topographic database, there should be a bunch of new files, which is the shapefile you just saved. One thing we learned in first period, and it was very useful working with different kinds of data, including GIS data, is creating different groups based on different values, different attributes we have in our data. Let's look at our data again using data.head. So now we want to get all the unique classes in our data. You remember how to do this probably from first period, so you can just write data. Then the name of the column we are going to use is class dot unique. So what this is going to do is to give you a list of all the unique values. So the same value, for example, for lake, you might have 100 lakes in your area, so that's repeated in your data. But this gives you the list of the unique values. So these are the unique values we have in our data, and now we are going to create groups based on these unique values. So let's call it grouped data. Again, similar to what we did in pandas. So data.groupby. And we are going to create our groups based on the field class. And let's print our group data variable. So now you have just created a group object. Let's take a look at our groups. So group data dot groups. So this gives you an overview of the groups you have. For example, well, you remember you just created the groups based on the class values, and it shows you, okay. And in the list in front of it, you have the index of the rows where you have that class value. So for example, there is only one row where you have this type of class. Some of them you have more. So now our data is grouped. So let's try something. Let's see how many, let's iterate through our group and see how many and count how many rows we have in each of our groups. Let's write a for loop. We will loop using key and group in our group data. And then we will print an f string. So terrain class for this row. Yeah, so this is a for loop. It goes through each of the groups we have, and it tells you how many rows exist in each of these classes. So if you want to work with just one of the groups, you can just obtain one of them. For example, if you want to get the lakes, we can do this, grouped data dot get group. The value for lakes was 36200. And let's check the type. So now we see that we just obtained the group that we want, which is lakes, and it's a geodata frame, so it's stored as a new data. So remember that our task here was that we have these different terrains and we are going to export them as separate data. So in order to do that, now we already created our group, so we are quite far with this task. Now let's create a for loop and go through these groups and export each of them as a new data. So for doing that, we write a for loop for key and group in data.group by. So we are just repeating what we did earlier, just in one neat line of code. We are going to create the groups based on class. So it goes through each of the groups and it saves them to a file that we specify. Let's save it in our topographic database directory. So it's going to create several files, one for each of the groups, to make sure that the names are unique. We want to give a understandable name for each of them, so you can pass in the name of the data file you're saving as an F string, so you can put like F. So we have previously used always F strings for printing. It's basically the same thing. You can manipulate. You can pass a variable into a string using F string, so it doesn't matter where you use it. In this case, we are using it in the name of the file. So it's now, we will loop through each of the groups and we will save it as terrain underline key.shp. This is shapefile. So now the data should be created. If you want to go check it, it's saved here in topographic database directory. Under your data, you can go see. Okay, let's try another thing, and that is to save summary statistics to CSV spreadsheet. So whenever, well, I said 20 times already today, the only difference between geodata frame and the data frame is that you have a column called geometry. If you don't have that column, it becomes automatically a data frame. So for example, if you calculate some statistics and in that file you don't have geometry, it's just basically a data frame. So you can, for example, export it as a CSV file. So for example, we can calculate the sum of the areas for each of our classes. The code is already written here. So it's calculated here. And you remember the syntax to CSV, so you can just export this file, what you just calculated, as a CSV file, which you can open in whatever program you want. Yeah, so that was a bit of GeoPandas. Do you have any questions from this part of lesson? It's quite easy because you have learned pandas already. It's not so different yet. You will see more in coming weeks. So if all is clear until here, let's do the last part of today's lecture, and that's working with coordinate systems, coordinate reference systems, CRS, and projections. Again, all of us have studied GIS before, so I'm sure you know what it is. And very often of course, you always need to know what coordinate system you're working with, whether you need projection or not. And very often you need to transform between different systems. So that is something that you cannot really avoid in GIS. So it's good that you can rather easily handle this using GeoPandas. So that's what we are going to practice now. So you remember that when you are working with shape files, it's not just one file. You have a bunch of files when you export shapefile, and one of the files you work with is .prj, which stores information about the projection and the coordinate system that you have. So if you are working with shapefile and you're copying the files, remember that make sure you have the .prj file, otherwise you can't know what projection system has been used. So let's now work a bit with coordinate systems. Again, let's set the variables, the paths that we are going to work with. Again, we are going to import GeoPandas. If you don't want to see that warning, just run this first. If you don't mind it, then you can just skip this part. So now we are going to use GeoPandas to open this data file. It's the border of European countries. It's in GPKG KG format. Let's just run this code that is already typed in. So if you want to check what is the coordinate system for this data, the syntax is very simple. So you have stored your data in this variable called EU_countries. If you just write .crs, it should give you the coordinate system that is used in the data. So you can see it's WGS84, and it also gives you the EPSG code for it, which is very handy. And a bunch of other information about the coordinate system. And what it gives you actually is another object. It's called a pipeproj.crs object. So the library that is used by GeoPandas to handle coordinate system related things is pipeproj. Again, another nice thing about GeoPandas, this library is built in, so you don't have to explicitly use that library. So let's take a look at our data. Well, from the coordinate system, we know that what range our longitude and latitudes should be in. And if you look at the geometry field, you can see that it looks all right. If you want to reproject your data to another coordinate system, again, it's very easy. So if, for example, you want to use the EPSG code for conversion, for the transformation, you can just write the syntax like this. So this is the name of your data, the variable where you have your data. So the syntax is just 2_CRS, and here you provide the name of the coordinate system. So in this case, we are using 30, 35. So let's use head again, and now we can see that the coordinate system is changed. So here we had degrees. Now the values have changed because the transformation was done successfully. And you see it's quite fast. It's very efficient, even if you're working with large data sets. So it's simple. Now in the rest of the lesson, we are just going to play with this a bit and just get a bit more comfortable with it. So now let's visualize our data, this European country's boundaries. Just in the last lesson of last period, we learned how to create these subplots. So now we are creating these subplots here. So they are the same data, just the coordinate system is different. One of them is in this coordinate system, the other one in this one. So let's just visualize it. So the data is identical. Of course, the coordinate system is different, so the map looks different. So for example, you see in WGS 84, it's not so suitable for Nordic areas. So the shapes look better on the right. Yeah, so now that you have transformed your data, so for example, you just want to transform your projection and just export your data, you can easily do that. Let's do it. We just rename it to EU countries and then the name of the coordinate system that we have used. Just export it. So now it's stored just as a new file on our My Work folder. So the coordinate systems you work with, you don't really need to know this, just like some extra detail. They can be represented, they're the same coordinate system, but it can be represented in different formats. So there is a PyProj format for it, there is a well-known text format for it, and there is a EPSG format for it. So using this syntax, you can view them. It's something you don't really need, but it's something that is available to you. So it's just a representation. So it doesn't affect what you're doing. It's just how it shows you the text representation of the coordinate system and different information you have about it. So you can see in the well-known format, you have a lot of details, like how is the ellipsoid defined and so many different details. One good thing about this PyProj library is that if you want to learn, of course, there are easier ways of learning about coordinate systems. You can just Google them probably, but it has a database with information about the coordinate system. So if you just write pyproj.crs and then you provide the name or the EPSG code of the coordinate system, it's gonna give you a bunch of information about how this coordinate system is defined. And there are a few built-in attributes. So if you just write CRS, once you create this CRS object, if you write, for example, CRS.name, it's going to give you the name of the coordinate reference system. If you, for example, write area of use, it shows you the area that it's suitable for. So yeah, so there are a bunch of links if you want to learn more about the projections in general and how it's handled in GeoPandas. You can follow these links later and read more about them. But now let's work with a bit different coordinate systems, more on global scale. So now we are going to work with world countries, so not just focusing on Europe. And we have a data stored in zip format. It's a shapefile that is saved in your data directory here, data directory in world countries. So let's just read that file. Let's visualize it, and we are using here matplotlib, something you used in the last period, to create a simple plot. So this is the world countries map with WGS84. Now let's use a different coordinate system. So now it's using Web Mercator, so it looks different. Now let's use Eckert. So different kinds of coordinate systems are available to you. You should just see which one suits your area of study, the scale, and you know how to use coordinate systems. And one cool thing is that you can also use orthographic projection that will show you the globe. So you can read more about this, but basically this is the syntax, and you also can specify where does the 0 of your coordinate start from, and also you can provide an area where let's run it, then it makes more sense. So now we have created this map, and it's centered on Finland, and the reason is that we have provided the coordinates here, so you can just create the map and specify where you want the map to be like centered on. Yeah, so it's pretty easy to work with coordinate systems using GeoPandas. So do you have any questions from this part? Yeah, if not, we can have a quick look at our exercise. So this exercise, so how was your experience with this auto grading in the first exercise? Did you like it better than the first period where we just ran it at the end of the course, at the end of the deadline? Was it helpful that you got this like immediate feedback?
Yes.
Yeah. Okay, so as I said, we only have it now for the first 2 exercises, but if this is helpful, probably we'll develop it for the rest of the exercises later on. Yeah, so let's check out the exercise 2. So the link is already there for accepting the GitHub Classroom assignment, but let's take a look at it on GitHub. Yeah, so basically what we did today, so create a polygon from a list of coordinates. So now you're going to work with, you are given 2 lists with longitudes and latitudes. So what you're going to do is just to create geometries from that in the first step. And then you're going to create a geodata frame from that. And then you just create a plot, a simple plot, and then you save your geodata frame as a file. So that's the first problem that you will solve. In the problem 2, you're going to work with a CSV file. So in the CSV file you have a bunch of columns, you have the latitude, longitude, and some other information. So you're going to read, using your Pandas skills, you're going to read the longitude and latitudes and create geodata frame and work with that. So again, you're creating geometries and then creating a geodata frame and then exporting it as a shapefile. And just create a simple map. Yeah, in the third problem, you're going to work with a shapefile which has travel points, so origin, destination for different individuals. So what you're going to do, you're going to import the data, group the data based on the user IDs, and do some calculations. You're going to create a line string That's what we did last week as well, because it's a line, and then you calculate the distance person has traveled, and then you have a few questions that you will answer, and then you will save the movement as a shapefile. Yeah, so if you have no questions, that was it for today. And again, remember, if you haven't already added your